The Orion Nebula, so glorious even in binoculars. Doesn't have the colors, but it looks like a puffy little cloud up there. And I want you to look at Orion's Nebula. Welcome, everybody, to the American Space Museum as we bring you this edition of Stargazer MarQ and some backyard astronomy. So we're glad that you're with us today. We got Selvin on the board. Marty will be back next week. Just had that nasty respiratory thing, and I've sent him all the well wishes from all of you there. But so we're going to talk today about a object in the sky that everybody's probably seen, and it's rising as it comes over the horizon, and that is the constellation Orion the Hunter. Okay, and I've actually got Orion the Hunter on this mug that Gary Allgaier got me. Thank you, Gary. Look at Orion there. It has to be hot to show the mug there, but there's Orion the Hunter as I have a sip of courage here. That's good. I got my vest on. Space Hipsters patch over here. Let's see, we are right here. I got to get we're right there at the tip of Florida there, folks. And that's where I do my stargazing now. Used to stargaze up in the mountains of Tennessee, but you can see Orion from anywhere in the world. It's on the equator, the celestial equator. So in the southern hemisphere, where Cliff Watson is right now, he's seeing Orion in the summer sky from Pomona, Australia. Hey, buddy. And it's upside down, just like everything is right side up here. So we're going to talk a little bit about this constellation that in mythology is really big. But in astronomy, it is a gigantic delivery room of newborn stars, including this distinctive pattern that you see here that we're going to talk about. Well, here's a picture that I enjoy doing. Taking this picture a year ago when we were doing, that is Kennedy Space Center, and that's Orion in the clouds above there. I'm going to get rid of this chair from a guest there. All right, and you see Orion right up there. The first thing you see are the three stars that make his belt together. And then on the left in that cloud is a reddish star, Betelgeuse, that we're going to be talking about. But it is a very easy to photograph. It looks gorgeous in the night sky, and you're going to see many pictures of it. There is the mythological look of Orion the Hunter. And I got my binoculars. I was looking around my neck. I had them around my neck just to give you a tip of stargazing. Cameras and binoculars need to be around the neck. So when you let go of them, you're not going to have to buy a new pair of binoculars. So that's what the strap's for, okay? Particularly you shutterbugs out there. Put that camera around your neck, not on your shoulder. You'll be glad when that you don't drop it one day. So binoculars are an excellent way to explore the sky, and there's all kinds of books about that. Just binocular astronomy, and we'll turn you on to binocular things in this program, like the Orion Nebula, we can see with the naked eye. Well, indeed, the bright stars of Orion. Let's look at him here. His shoulders. Selvin, that's doing it again when I hit the enlarge. I have to hit the image button, so we'll investigate that later. Here are the key star names of Orion. All of them are second magnitude, we call them. Very bright. Some of them, about 6 of them, have something in common, meaning they may have come out of a cluster of stars like the Pleiades in our sky that we'll talk about on a Stay Curious. In mythology, Orion is dominating in many cultures. The Greeks saw him as an amazing hunter whose prowess of his ability to kill anything. Alarmed at Orion's savage intent, the earth goddess, Gaia, sent a scorpion to kill him. That wasn't nice of you, Gaia. And Scorpio is on the opposite side of the sky, rising when Orion is setting. So indeed, about 9 o'clock at night, Orion is, pretty high up in the sky, but not quite overhead. And by 10 or 11, it is more directly south. And that is where Scorpio is in July and August, just like Orion is in the south of the sky right now. The symbolism of death and renewal was born between these two celestial creatures in a lot of mythology. In Egypt, Orion represented the god of the dead and the first king of the land, Osiris. And we just had a spacecraft named Osiris Rex that brought back a piece of an asteroid. It is said that 5 of the ancient pyramids of the Giza Plateau were aligned to represent Orion and its stars, and the belt of 3 stars were markers in the pyramid shafts 5,000 years ago, which is true. You see those 3 stars together in a row, there's no pattern like that in the sky, and then you've got obvious stars for the shoulders and knees of a dot to dot of a person as you outline it in the sky. Well, you got these 7 bright stars outlined Orion, all have names from Arabic. Interestingly enough, the constellations are named after Roman gods, all right, and it is the Arabic that a lot of the names of the individual stars are, and then we have Greek letters that are used to denote the stars that don't have names. So it's quite a mix of cultures in the sky when you look at a chart with the names, individual star names, and the Greek alphabet denoting some of the stars there. So well, let's look at some of these star names. Let me go here. Let's see. There we go. We have Betelgeuse, which there is a reddish star we're going to talk a lot about, because when you look up at Betelgeuse in the sky, we want to look at it every night to make sure it doesn't explode, because this is a gigantic star, one of the largest stars we've ever discovered in the entire universe, and it's going to explode one day. It might explode tonight, it might explode next month, it might explode 10 years from now, or 1,000 years from now, but we're pretty sure it's going to explode within the next 100,000 years, and that will create a supernova bright star that will be seen in daylight and maybe even cast a shadow in daylight. Well, Betelgeuse, Selvin, in Arabic means armpit of the giant. Betelgeuse means armpit, okay? Bellatrix, the other armpit, means female warrior. While Saf is the sword, all right, Saf is the bottom right knee, and Orion's brightest star, Rigel, is the giant's leg, and they make up the knees. The 3 belt stars also have names, Mintaka, Al-Nalam, and Al-Natak. Al-Natak means the girdle, Al-Nalam means the string of pearls, and Mintaka means the belt. So Mintaka, I like saying that. That's a good name for a cat, maybe. Come here, Mintaka. Wonder if CB's watching. Would that be a good name for a cat, Carlton Bailey? Mintaka, come over here. The celestial bull motif for Taurus, the bull, has been recognized for many years too, and is around this. All right. There you've got again the outline of Orion in the sky as it's rising up. Now, when it gets dark, it looks about like this. Of course, the Earth's turning, keeping it rising by the hour, and by 11 o'clock to midnight, it's directly south. Again, a plethora of well-known constellations surround Orion. It's a key to finding Gemini, the twins, Taurus, the bull that looks like a V. The Pleiades are this little cluster of stars that look like a little dipper. Those are right there in the shoulder of the bull. And the brightest star in the sky is also just below Orion, and I'll tell you what that is. Stay curious. Here again, a little clouds in the sky. Doesn't matter. All right, your picture's taken on a tripod with an exposure of like 30 seconds with 2000 ISO on your sensitive range are going to yield you a picture like this. And as the exposure is a long exposure, like 30 seconds, the clouds might move and give you a beautiful pattern up there like these did. So you need a tripod, and I also recommend you use the self-timer on your camera. It's a little hour looking hand, or it's a clock looking feature, and you can go from probably 5 seconds to 10 seconds to a self-timer. That takes all the shake out of your finger mashing the button on that camera or cell phone. Here again, a picture I took, an outline. There's Taurus the bull above Orion. So you look at the pattern of the three stars, you see that, and then you also see the V of Taurus the bull there. That's the head of the bull ramming through the sky. Well, let's look at some detail here of some of the wonders of this constellation. When you look at this constellation, you are seeing things that you can't see. That's a silly way for me to put that the human eye cannot see sensitive things that the camera can, or camera at different wavelengths. We talk a lot about wavelengths in science. The wavelengths are the different areas of the spectrum that are sensitive to, for example, light. That's just a very narrow end of this, very little part of this electromagnetic spectrum of energy emits light. But that's all we see with our human eyes. If we could see infrared and hydrogen in our skies, then that would be something else. And I knew that was going to happen. I set my phone there. Apologize for that. So there's things in the sky that with special filters are there, but we can't see because the human eyesight is limited. That's why you have X-ray telescopes. That's why you have the gamma ray telescopes that only look for gamma ray sources. Okay, the Webb Telescope is looking at infrared that we can't see. That's heat emitted energy, or infrared. And then we can't see other wavelengths of light, like radio. Other wavelengths of energy, not light. Light is its own wavelength. Energy is in the form of radio waves, all right? FM, AM are different waves. So why I'm emphasizing this is because when you look up at the night sky and we see Orion like this, the 3 stars of the belt, the 2 stars of the shoulder, the 2 of the knee, and the sword dangling down, you see in the middle of that sword doesn't look like a star. No, that's the great nebula of Orion, a large nursery of stars that we thought was tremendously big until we looked at it in a different kind of light. I'll show you in a minute. Now, these stars of Orion that give this pattern have very little to do with each other in a relationship of distances from each other. And this graphic shows you real well that they are all in different distances from the Earth, or our sun more specifically. And let me get my notes on that we have Betelgeuse there, a very close star to us, all right? Less than 300 light years away. So the light that we're seeing Betelgeuse is 429 light years away. So the light that left there was in the 1500s. Bellatrix, the other armpit, is a little bit closer. There you see Alnilam, Mintaka, and Alnitak, the 3 stars of the belt, are distances of 1,300 light years to 900 or 800 light years away. So it is like looking at a row of telephone poles lining up. And they have a certain pattern going down the road, and when you turn left, the pattern changes to those telephone poles. This is what these stars line up to look like from our perspective on Earth. We're looking at from 90 degrees of Earth, and they wouldn't line up like a man in the sky. So this is all arbitrary, the dot-to-dot patterns in the night sky. Here we have 310 light years for the giant Betelgeuse, a giant red star that would fit in our own solar system. It would swallow up Mercury. It would swallow up Venus. It would swallow up the Earth. It would swallow up Mars. It is so gigantic. And we're going to see the surface of this with the Webb Telescope. We think there could be star spots on it, but we witnessed a burp or an eruption off of this star 2 years ago that was quite fabulous, that made it dim and go dimmer. And I witnessed this looking up at Orion one night. I'm going, oh my gosh, it's not as bright as it was, because it's usually as bright as Rigel there, 0 magnitude, just a little bit less. And it was definitely dimmer. And was it about to explode? Well, I'm going to tell you in a minute what happened. So there's the distances in light years. The Great Nebula of Orion is 1,300 light years away. All right. So that light that we're looking at tonight in binoculars, in a telescope, with your naked eye even, left there in 1,300 years ago. I'm trying to do the math here. We're at 2024, so you're talking 1676 is when the light left here. 1676. What was happening then, Selvin? I forget. Our country was pretty young, not even a country yet. All right, pilgrims learning how to grow this thing called corn from the natives. So it's fun to look back and think about that. Now, Saf, the knee on the left, that is as far away as the Orion Nebula. Now, if we put that Saf that's 1,300 light years away as close to us as Betelgeuse is 300 light years away, it would shine so bright. It shines bright now, but it would shine so bright it would cast a shadow in the daytime. All right, and you'd probably be able to, it'd just be read a paper maybe, or read something under the light of it at night. So we're lucky that some stars are far away and some are close because of that factor. Well, here's a picture I took with a star filter on the mighty Orion, just to give it some pizzazz there. And you can try to do this. The filter works on, you screw it on your lens, or you can hold it in front of any of your lens or your camera. And post-production will do this sometimes too. But when we look at the unseen, you're not going to believe what Orion looks like. If I could see in hydrogen alpha, just the most prevalent material in our universe is hydrogen. And it is escapes our human eyes to see where it is exactly in rarefied form. And it goes from here to here. Look at that. The unseen gigantic cloud of Orion is one of the largest nurseries we can find in the University for Stars. Okay. This great Bernard's Loop, they call it. And Bernard was a famous astronomer who discovered this by using a different filter on photography to reveal this. You cannot see this with your eye, even with a filter. This is a photographic, and this is a incredible photographic image of over 8,000 images stitched together by my friend Matt Harbison from Chattanooga, Tennessee. And Matt Harbison has gotten lots of awards for this incredible photo, where he spent over 3 years just shooting a different little tiny section of that and then stitching it all together with a backyard telescope, not even a major university telescope. But this is what Orion looks like if we could really see what's going on in the sky like that. Pretty incredible, isn't it? So we're going to look at a few of these wonders up close, particularly the Orion Nebula there that is real bright there in this sort of off of the belt of 3 stars. Okay. There it is again. All right. And that's really, if you could see infrared hydrogen, that's what it would look like. Not infrared, hydrogen light. Incredible. So let's talk about Betelgeuse. Betelgeuse is called Alpha Orionis. Alpha, beta, gamma, the alphabet of Greek is how they give the brightest star to the different stars. They use double letters to go through the alphabet. The size of the star, like I show there's the size of the Earth's orbit. There's Jupiter's orbit. So it's would almost reach to Jupiter if it was put in our solar system. And we think it's so huge because it's at the end of its life. The hydrogen has turned to helium, and helium is lighter and expands out like a big bubble, like one of those big yard bubble things you play with. Not that Betelgeuse, okay? We're talking about this Betelgeuse, all right? And there is Betelgeuse through the Hubble telescope, the best images. And what happened was it went from bright to starting to dim to something blocked some of the light on it. And that blocked the light here in theory was proven to be fact, that a gigantic explosion on Betelgeuse threw off material that cooled and acted like a shield in front of it, dimming the light for about a year. This was from January 2019 January to December 2019 is when it dimmed pre-COVID days up there. So this was quite an event, all right. And for us to observe this at this time and space in history of the Earth was quite fortuitous because of all the technical telescopes and stuff going around. Not just the Webb Telescope and the Hubble, but the European Space Telescope called Kepler that doesn't get enough love. And we're going to talk about that on one of our Stay Curious Backyard Astronomy segments. So, also, Betelgeuse was in the news because an asteroid passed in front of Betelgeuse December 11th last year. And this was it was over the tip of Florida and Miami, and there was a big buzz about it that it was going to make Betelgeuse completely disappear. All right, so can you imagine looking, not that Betelgeuse, but looking at Betelgeuse up there, and all of a sudden it kind of winks out for a second or two. All right. And I almost drove down there for that, Selvin, but I'm glad I didn't because it was sort of a non-event. The asteroid maybe wasn't as big as they thought it was, or was going real faster than it was, and it didn't really wink it out like we thought it would. So, well, let's get back to the beautiful Orion, and I think I've drilled it in your head what it looks like, but also enjoy the colors. Look at how those 6 of those stars, the 3 in the belt and the 2 knees and the 1 shoulder, are all brilliant blue. Well, they're blue, gigantic blue dwarfs, super bigger stars. By bigger stars, I mean 100 times bigger than the Earth. I mean our sun. Our sun, in fact, is not really an average star. It's a kind of a small star, as far as small stars are called. But the red star, Betelgeuse, unmistakable. But let's go into this Orion Nebula down there and really see what makes this tick. Again, a photograph just with a 100mm lens, a little bit of a telephoto, and guided on a little mount there for about a minute. But look at the beautiful red in that belt of the Orion Nebula. Now to the left, the bottom star Alnitak, on the left-hand side of the belt, we're also going to see an incredible feature there called the Horsehead Nebula that is very difficult to see with your own eyes and not easy to photograph either. It didn't show up in this photograph, and I was kind of surprised it didn't. But there's the Orion Nebula. Kind of looks like a clamshell, and the orientation might change on how I'm showing this, but it doesn't matter because there's no up or down in space. But when we're looking at this, we tell people that this is a dark cloud, that inside of it is the birthplace of hundreds of new stars. And here's a beautiful photograph taken by my friend Mark Poole on India Atlantic, about 30 miles from here on the Atlantic Ocean. And this is his beautiful picture of the Orion Nebula. And you see that there's other clouds blocking. That's what the dark is between that and the stars on the left. It's called the Flame Nebula. Another beautiful Orion Nebula taken by my friend Matt Harbison. Look at the inside is so overexposed. It's just white. All right. Now, in a telescope, you can see that where that white is inside that clamshell are 4 stars. And we call those 4 stars the trapezium because they look like a trapezoid. They are overexposed in this image to get the delicate gaseous nebula. Now, this we're looking at 1,500. How big is this from end to end? I want to not be. It's 15 light years in diameter. All right. So light from where I'm at to the top takes 15 years to travel, going at 8 trillion miles an hour. 8 trillion miles an hour. Okay. I'm sorry. It goes 8,000. It goes 8 trillion miles in a year. It's 186,000 miles a second, or 7 times around the Earth's equator in 1 second. Well, there's even a bigger cosmic cloud behind this, like we showed you. with that. This is the closest giant star-forming region to the Earth. All right. And it's 1,300 light years away. And we have on this show about the Starlink satellites that are going up twice a week off our coast or the Vandenberg coast in California. And why astronomers are complaining about it, because a friend of mine took this photograph of the Orion Nebula, and he had some of those Starlink satellites cross through it during the exposure. Now, no big deal, just take another picture, right? Well, it is a big deal, because taking astrophotography is just not like taking a picture of a flower or the ocean or your friends. There's a lot of variables involved there, and one of the biggest is the weather. And wind can affect jiggling your camera, telescope, all kinds of factors. So once you get it set up, and this might be a 15-minute exposure, that this has passed through and ruined it. Now, there's software to correct for that, yes. And this is just not a problem the backyard astronomers, which you can take a picture like this from your backyard, but professional astronomers too on the mountains around the world. I'm going to go back to the other one so you see a great picture there. You see the clamshell, and on the left, it's sort of like new stars have busted through, and you see that clearly here on the left on there. Another gorgeous shot that they've adjusted. This is many different pictures layered, so you can see those stars inside that are on display there. The trapezium there. And what we have incredibly discovered with the Hubble telescope and the Webb is going through it. On the other side of a piece of the Orion Nebula, not ready for that yet, in one of those little portholes there, the Hubble telescope imaged right through it. And there's a galaxy behind on the other side, and a bright star that's in our galaxy behind this incredible shot of star birth. Now, this area here is probably from here to our nearest star, maybe 2 or 3 light years away. The nearest star, Alpha Centauri, is 4 light years away. All right. The brightest star in our sky is 8 light years away, Sirius. So when you look more detail of these things in the Hubble telescope, they've come up with these strange objects. And what those are 4 solar systems being created before our eyes. This is what astronomers call protoplanets. All right, these protoplanetary systems. There's a big star that's ignited in the middle, and I don't know how big the star is, but it has to be a certain size to ignite, like our sun did. And then all the debris around it is coalescing like around it, like into planets and asteroids and comets will be the leftovers at the very end of this thing. And we, in the 21st century, are watching this happen before our eyes. Now, it takes maybe 1 million more years to develop a whole planetary system. We're not sure about that yet. But as we look at things with these great instruments that we put into space, and even the instruments on Earth that are being more refined, when we discover things, we learn that we don't know what we don't know. And what we've learned is being altered all of the time. And I'm going to show you here in a few minutes one of the incredible discoveries of the Webb Telescope that has astronauts thoroughly scratching their heads about what's going on. Just after I show you this, another incredible picture of the Orion Nebula, taken with a little different heart. You see on the left side are those stars I'm talking about. That's like a cave to be explored there, that blue light with new stars in it. Same way on the right side, the red is hydrogen concentrated in the Orion Nebula, and they theorize over 1,000 stars are being born here. Some of them, we see their bright energy right now. But as they looked at the Webb Telescope images of this, they discovered these objects, and this is a new discovery here in the last month called JUMBOs, Jupiter Mass Binary Objects. Astronomers have found 40 pairs of objects all in wide orbits around each other. So what we're looking at here, the arrows are pointing to two, what we would say stars. There's 5 of them there. In the inset above my head here, that you're not going to see that unless I move, or I can put it up here. The inset shows you a close-up of those where there's actually 2 stars, and one is a pair of 3 stars, the second panel, that are orbiting each other. But I correct myself. The thing that blows astronomers' minds are these are not stars. These are objects, solid objects that they are star formed from giant clouds of gas and dust that collapse beneath gravitational forces. This process continues as disks of gas and dust swirl around stars, giving rise to planets. But there's no theory existed to how planets, which these are, could form away from a star. Or why are they in the Orion Nebula? All right. So these are 40 pairs of planets that are orbiting each other. Some are, they theorize, about half the size of Jupiter, and a couple of them are 13 times the size of Jupiter. So they're maybe more like the size of Uranus and Neptune, and then a lot larger than Jupiter. But astronomers they call it upending the rules of astronomy. We don't have any theories of how to create planets or hard bodies that will have hard surfaces or gaseous with gas around them. Maybe we have no way to theorize how these can be created without being in this that I showed you earlier, a torus, or a ring of debris orbiting a star, and this debris, like clumps of snowflakes, are getting bigger and bigger and bigger as they run into each other, and eventually you have a snowman. So this is really a breakthrough thing of what these jumbos are, they're calling them. And here is a picture just released a week or so ago to show you this amazing astronomy thing. It's incredible that planets can, where'd they form? Now we know that there's planets that are rogue planets that do not have a star to them. They may have been ejected from that star by some cataclysmic event. So again, astronomy is one of the greatest sciences, the oldest of the sciences, because it's always refining who we are, where we are, and what is it we're looking at. Well, let's look at a couple more pretty pictures here. The Orion Nebula. Let me make this full screen there. And again, that same picture I took to show you that the left star there has got the Horsehead Nebula in it. And that, the square above my head there, shows you where the Horsehead Nebula is. I've seen it one time in a telescope, a very large telescope, with it was very difficult to see. We had a bunch of filters stacked on a 36-inch Dobsonian mirror telescope down at the Winter Star Party in the Florida Keys. And I know at least 100 people finally saw it. Looks like a little bean. If you don't, right there, it looks like a horse head. Indeed, there's another image of it. Also kind of looks like a woman's face with hair blowing off of her. But some of you would say that, yes, I would say that. This is another hotbed of stars being born, all right, on the left side. That's sometimes called the Flame Nebula or the Christmas Tree Nebula, all right. And here's another close-up. Now you're seeing more of the Horsehead, all right. This is from the Kepler telescope, a beautiful telescope that the European Space Agency has been operating. You kind of get the horse feel there. And there's the Horsehead Nebula. Now you get it in infrared and visible light through the Hubble telescope. Gorgeous, isn't it? And what does it look like through the Webb telescope? A little bit more refined Horsehead Nebula there. What do you think of that, huh? Of course, that's a little bit of tongue-in-cheek there, okay? But a lot we have fun in astronomy, making fun of the objects that we give names to, okay? But there's the Horsehead Nebula, and a pseudo Webb Telescope image of that there. So, well, as we're winding up here, wanted to just talk a little bit about Orion in general. Here's some meteors streaking out of the Orionid meteor shower that peaks in October 24th, around the 21st, 24th in October. These are fragments of Halley's Comet that we're seeing. Like I said, Orion sits on the equator, thus he's upside down in Australia, South America. It takes little imagination to see the Hunter. There you go. You see the 3 stars of the belt, and then the rest of it fits into place. What phenomenon have I captured here? Some sort of strange meteor? No, something you can get all the time. 2 airplanes, okay? Actually, it's not 2 airplanes. The one on the left is an airplane because those scored marks are the lights flashing off and on the airplane. So what could the bottom one be? Coming off Rigel, the knee star there. A meteor? Nope, that's the International Space Station that I captured on a pass not too long ago. And purposely kind of had it emanating out like stick figure there. And again, an airplane going through it there that where the lights broken up there. So pretty cool that you can get different things at different times going through. And Orion, yes, our spaceship that's going to be orbiting the moon attached to the Gateway Space Station is called Orion, and there is the Orion Artemis 1 mission. That is a real photograph. They had a camera at the end of the solar panels, and I love the light looking through the windows there. And unfortunately, it's going to be easily November 2025 before we see that again. So bid adieu to Orion. Hope that you've enjoyed looking at this constellation, and go out and see it tonight in a different light. I know many of you up in the northern hemisphere, it's hard to see the stars through all the clouds, but it's worth it going out. This is a constellation you can even see when the moon lights out. And you take those 3 stars of Orion's belt, and you don't have to use them as a pointer because Sirius is the brightest star in the sky, and it's up there for you all to enjoy. One of the most important stars of antiquity. The ancients, Egyptians, very important to them because in the spring it rises when the floods start, and it's up in the sky during our winter time. And so it is the brightest star in the sky, 8 light years away, in the star Canis Major, the big dog, and the Hunter has his little dog beside him, Canis Minor, which is also a bright star called Procyon. And the armpit, Betelgeuse, and Sirius at the bottom, and Procyon on the left make the winter triangle. There's Sirius through a telescope. It has a very small star orbiting it that they call the Pup because of it being in Canis Major, the big dog. So, well, thank you all for spending your time to watch Staying Star Curious with us here on Stay Curious. A little bit of backyard astronomy and a star that you can certainly see, a night full of stars. We love the winter here in the American anywhere because you have over something like 12 of the 13 bright stars of the brightest 20 stars. About a dozen of the 20 brightest stars you can see in the night sky tonight. So get you a star chart. You can download one anywhere there's a star chart. Even an old encyclopedia of grandpa's will have a star chart in there somewhere, and it applies today because the stars never move in eons of time, though they are moving fast. They're just so doggone far away. Well, Selvin, thank you for doing a good job today. Who we want to say hi to today?
Well, we got Doug Forrest, Steve BJ, Dave Stengy, Mark Uziak, Robert Law, Carlton Bailey, Tom Uziak, and William Whiting.
Well, thank you all, our A-lister friends there. We're going to talk about you all tomorrow on Stay Curious, all right? Particularly the Lake County Spaceport, we're going to educate you to, and Steve's wonderful operation there. that I've been meaning to get in front of you all, but will. And we appreciate everybody watching us, and your financial donations are much appreciated and are used to do good things here, like improve our set and equipment here. Stay Curious is in the works, as well as outreach for things. So we are putting together a list of things we're doing in 2024, and we'll be telling you all about them. So stay tuned. So until tomorrow, when I talk about some of our great contributors out there, and do a little bit of shuttles of the month of January, and maybe throw Jupiter and Saturn in there too, because they're up in the sky. Until then, I'm Marquette saying I can't wait to see you again to bridge the space between us. Thanks for the